Malaysia, Associate Professor Karel Svatlenka from Kyoto University, and also Associate Professor Terry Wijaya from Boston University. Distinguished participants, both online and offline, all presenters, ladies and gentlemen. A very good morning to you all, and welcome to Ijen Suite Resort and Convention Center Malang. We are very honored and happy to have you all here today on Tuesday, September 13th, 2022, for the opening ceremony of the BaSiC Science International Conference, talking about basic sciences technology for nourishing community life post-pandemic era. This annual scientific meeting is organized by the Faculty of Science, Brawijaya University, and this meeting aims to promote mutual exchange between scientists and also experts to discuss innovative ideas in scientific research. We do hope you will obtain so many benefits by participating in this international conference. Well, ladies and gentlemen, to warm up this morning, may I have a big applause to this event? May I have the big applause to this event? Thank you. My name is Childa Maulina, and I'm honored to be Master of Ceremony today. On behalf of the organizing committee, we extend our appreciation for your presence, and we are very excited to be along with you all here today at this ballroom. It is such a great opportunity for all of us to interact and network with peers and colleagues across the academic environment. Honorables, distinguished guests, ladies and gentlemen, this event will be held for 2 days. As being informed on the schedule, the day one of the conference will be conducted both online and offline. There will be opening ceremony, and then plenary session 1 and 2, and also continued by 3 simultaneous parallel presentation online at this ballroom. While the day 2 of the conference will only held online, there will be plenary session 3 and 4, and continued by online parallel presentation, and finally ended by closing ceremony and awarding of the best presenter. That was a glimpse of the schedule for our today's international conference. And honorables, distinguished guests, ladies and gentlemen, without any further ado, we would like to request you all to arise because we would like to commence this program by singing national anthem of the Republic of Indonesia, Indonesia Raya. Kindly be arise. Thank you. Kindly be seated. Before we move to next agenda, let us spend a few seconds to pray together in order that the BaSiC Science International Conference can run smoothly and successfully. Prayer will be led by Mr. Ratno Bagus Edi Wibowo, PhD.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Let us bow our head for a moment. Pray to God, Allah subhanahu wa ta'ala, so that our international conference can be precious to all of us. I will lead this prayer based on the teaching of Islam. And those who are not Muslims, you are pleased to pray according to each of your belief. Bismillahirrahmanirrahim. Allahumma salli ala Muhammad wa ala ali Muhammad walhamdulillah rabbil alamin. Hamdan yuafi ni'amahu wa yukafiu mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalalika wajhikal karim wa azimi sultanik. Allahumma inna nas'aluka salamatan fid din wa afiyatan fil jasad wa ziyadatan fil ilmi wa barakatan fil rizqi wa taubatan qabla al maut wa rahmatan 'inda al maut wa maghfiratan ba'da al maut. Allahumma hawwin 'alaina fi sakaratil maut wan najata minan nar wal 'afwa 'inda al hisab. Allahumma ighfir lana wa li walidina wa li masyayikhina walil muslimina wal muslimat wal mu'minina wal mu'minat al ahya'i minhum wal amwat innaka sami'un qaribun mujibu da'awat ya qadiyal hajat. Oh Allah, today in this beautiful place we gather here to bring about BaSiC Science International Conference. Make this international conference as a useful science assembly, as a medium of sharing useful ideas, knowledge, and experiences of scholars, researchers, and students of various disciplines. May the conference we organize today benefit to our lives, broaden our knowledge, shine our idea, and lead us to be successful, productive persons, which in turn will be boost dignity of our nations. O Allah subhanahu wa ta'ala, guide and bless our heart and our mind with the light of your guidance. Impart your supreme wisdom upon our activities. Help us to speak our mind clearly. Help us to listen to each other, respect each other, love each other, so that we are included to the blessed persons. O Allah subhanahu wa ta'ala, protect us from unintended temptation, show us the right path, and give us knowledge and strength to perform good things. Equally, show us and make it clear the bad thing and to give us knowledge and strength to avoid them. O Allah subhanahu wa ta'ala, Ar-Rahman Ar-Rahim, you are the one who can fulfill our dua. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzaban nar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Ratno Bagus Edi Wibowo. We will continue our event by presenting the welcoming speeches. For the first speech, I would like to invite the Basic Science Chairman to deliver a welcoming speech. For Ibu Ana Safitri, PhD, time and place are yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. On behalf of the organizing committee, I would like to welcome Vice Rector 1, Brawijaya University, Vice Rector 4, Brawijaya University, Dean of Faculty of Science, Dean of all faculties in Brawijaya University, Head of all departments in Faculty of Science, our keynote speakers and our invited speakers, all presenters, and also all participants. Welcome to the 10 Basic Science International Conference, or Basic Science 2022. So the Basic Science 2022 is actually an annual international event organized by Faculty of Science. But our last Basic Science, the 9 Basic Science, was held in 2019. And then we've been vacuum for about 2.5 years before we began our 10 Basic Science this year. So we really grateful that this year the pandemic COVID-19 is almost finished or maybe still going on, but due to the vaccine and also booster vaccine, we can now together in this occasion for Basic Science 2022. Basic 2022 will run for 2 days, 13 and 14 September 2022. This year's theme for Basic 2022 is Science and Technology for Nourishing Community Life Post-Pandemic Era. And we have 8 related topics, including chemistry, computational and modeling, physics, material science, environmental science, molecular science, mathematics, statistics, instrumentation, and new and renewable energy. This year conference will be held as a hybrid conference due to we still have COVID-19 pandemic. Around 660 people are attending this conference. They consist of 120 presenting presenters, 20 non-presenting participants, 9 keynote speakers, and 5 invited speakers. In terms of country of origins, we have participants of the Basic 2022 coming from 8 countries, including Indonesia, Thailand, the Philippines, Japan, Malaysia, Gambia, and Australia. The Basic 2022 covers broad range of research in the field of science and technology forum, and also provides a platform where national and international academia or researchers, policymakers, and other stakeholders can be together to translate technology, exchange ideas, and help stimulate multidisciplinary in international collaboration. Basic 2022 event genuinely highlights the importance of recent advances in science and technology research to address community life in post-pandemic era. The Basic 2022 could not become a reality without help and assistance of many parties. Thus, in this occasion, I would like to sincerely thank to our keynote speakers, Professor Aulani Am from Brawijaya University, Professor Satmito Jati from Brawijaya University, Professor Terry Matt from Universitas Indonesia, Professor Andrew Clayton from Swinburne University, Associate Professor Dr. Nazri Saleh from University Putra Malaysia, Associate Professor Dr. Dery Wijaya from Boston University, the USA, Associate Professor Dr. Karel Svatlenka from Kyoto University, Japan, Associate Professor Dr. Jairot Kisopsanton from King Mongkut University of Technology, Thonburi, Thailand, Associate Professor Dr. Aji Ahmad Rinaldo Fernandez from Brawijaya University. Also, I would like to thank our invited speakers, Rector of Universitas Brawijaya, Dean of Faculty of Mathematics and Natural Sciences, Brawijaya University, and all members of the organizing committee who have provided meaningful help and assistance for the implementation of this conference. Finally, we have tried to do our best to prepare this conference. However, there is nothing completely perfect in the world, including this conference. Therefore, please accept our deep apologies for any inconveniences found in this conference. Please enjoy BaSiC 2022 and your stay in Malang. Wassalamualaikum warahmatullahi wabarakatuh.
Well, that was the remark delivered by Ibu Ana Safitri, PhD, as the chairman of the committee. Ladies and gentlemen, the next speech is the opening speech from Rector Universitas Brawijaya, which is represented by Vice Rector 1 or Vice Rector of Student Affairs. Please welcome Professor Aulani Am.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm to be here this morning, represent Pak Rektor, Prof. Widodo, as Rector Universitas Brawijaya. On behalf of organizing committee of BaSiC 2022, I would like to extend my warmest welcome to all delegates BaSiC 2022. Welcome to Malang, one of educated cities in Indonesia. There are about 40 university plus in Malang. Of course, the largest university in Malang is Universitas Brawijaya. This year, Universitas Brawijaya ranks behind Universitas Indonesia, behind Universitas Gadjah Mada in bibliometric rank. But the first rank also in impact point in bibliometric rank. I would like also to this opportunity to express my gratitude to conference committee, Ibu Ana Safitri, and team, the Dean of Faculty of Science, Professor Sasmito, for this conference today. I would like also to deep appreciation to all keynote speakers, invited speakers, all participants as well. Ladies and gentlemen, BaSiC is international conference conducted every year, organized by Faculty of Science, Universitas Brawijaya. For this year, BaSiC 2022 is the 10th international conference. Starting in year 2011 at the first international conference, the BaSiC 2019 is the last BaSiC then we have 9 conference. The BaSiC conference has been vacuum for 2 years due to COVID-19 pandemic. Therefore, BaSiC 2022 is remark the Faculty of Science start their international academic activity. Ladies and gentlemen, BaSiC 2022 aim to promote mutual exchange between scientists and experts to discuss of new research results in the field of science and technology. The conference will facilitate researchers and academic member from university, government institution, private sector, and non-government organization to share their knowledge through the discussion on plenary session and parallel session of the oral presentation. This year, the topic of BaSiC 2022, the science and technology for nourishing community life post-pandemic era. This topic is suitable with condition of our nation here. We are ready to recover face this danger as a motto of the 1777 Independence Day, the Republic of Indonesia. Also this year, Indonesia is the host of G20 meeting headed in October 2022. I believe that BaSiC 22 should bring advantages for all participants. They will learn many new aspects of research in related topic, either from keynote, speaker, and general participant, of course. In addition, collaboration between Universitas Brawijaya and other universities, both national and international, can be initiated. I noted that researchers cannot work alone to produce research result that is ready for downstream. Again, I would like to express my gratitude to keynote and invited speaker BaSiC 2022 for the expertise and knowledge that they will bring to the conference. And of course, the one discussing in the talk. Special thanks also extended to a member of organizing committee for their hard work and bringing this conference together. But not least, I would like to thank to all of conference participants who will contribute to making the most memorable BaSiC 2022. As for the end of our speech, I will also officially open BaSiC 2022 by saying Bismillahirrahmanirrahim. Please enjoy BaSiC 22 and have a delightful seminar. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Aulani Am. Please remain to the stage because we will have a group photo before we move to plenary session 1. Please come to the stage, the Dean of the Faculty of Science and also Vice Deans. And the Dean of Faculty of Health of Brawijaya University, please come forward to the stage.
All Dean
And all Dean in University of Brawijaya, please come forward to the stage because we will have a group photo first before we move to plenary session 1. Oh, okay, yes, please. Ladies and gentlemen, we will have twice a group photo. First is the leader of Brawijaya University, and then the second is for the participants. Kindly you open your mask, maybe. Would you please to open the mask? Well, thank you. Please still remain in front of us. Please come forward, all the participants maybe who will get a photo with our leader. Please come forward. Yeah, we will have a group photo. Because this will be something we will memorize. Would you please? Okay, thank you very much, ladies and gentlemen. Kindly return to your seats. Thank you for the coming of the Dean of Health Faculty. We will commence to the next agenda. Honorables, distinguished guests, ladies and gentlemen. Let's begin our plenary session 1. We would like to invite all the speakers on the stage. Professor Dr. Aulani Am from Brawijaya University, and also Associate Professor Chairat Trisapsunthon from King Mongkut University of Technology Thonburi, and also Associate Professor Muhammad Nazri Saleh from Universitas Putra Malaysia, which is come online. And to lead this session, please welcome our moderator, Ibu Anna Safitri, PhD. The floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. We meet again. Okay, for the first plenary session, we will have 3 speakers, Professor Aulani Am from Brawijaya University, Associate Professor Muhammad Nazri Saleh from UPM Malaysia, and Associate Professor Dr. Chairat Trisapsunthon from King Mongkut University of Technology Thonburi, Thailand. For the first speaker here, we will have Ibu Professor Aulani Am from Brawijaya University. Before Ibu Prof. Aulani Am begin her presentation, we will display her short CV. Operator, please. Okay, this is the CV of Professor Aulani Am. Professor Aulani Am is currently now is our Vice Rector 1 in Brawijaya University in Academic Affairs. And then this is the interest, her interest of research are biochemistry, animal ethics, and animal welfare. I cannot see from here. And the education, she obtained the Doctor of Veterinary Medicine from Airlangga University, and then MSc in Biomolecular Chemistry in USTPL Montpellier, France, and then PhD from Medical Biochemistry Airlangga University Indonesia. From the publication, there's a lot of publication that Professor Alan M has published, a lot of publication. So the Scopus and the Google Scholar Index are quite high. And then for the patents, she also obtained many patents in Indonesia, 7 granted and 3 registered. So without further ado, I would like to invite Professor Aulani Am to give her presentation. We will help for the share screen from the operator to display her presentation. Professor Aulani Am will have 30 minutes maximum. Thank you.
Thank you, Bu Ana Savitri. Also, thank you to the committee as well for inviting me to be here for presenting our research on title autoimmune thyroid disease detection as awareness precaution on post-pandemic era. Ladies and gentlemen, at the start of university research, how is the condition research downstream in Indonesia or actually in higher education at the era of industrial evolution 4.0? National Research Master Plan 2017 and 2025, research is the main motor to produce invention and innovation, which in turn have an impact on increasing the nation's competitiveness. So, improve the science and technology-based economy. There are two units, higher education and industry. The task of higher education actually is process technology development, and the other side's industry is based on the cost economic benefit. So, two units must work together as a transnational research. Why? Because transnational research is to close gap between we researcher in university and practitioner in industry. Research should be downstream in higher education. The task of higher education is to implement the Dharma, education, research, and community services. University researchers have done a lot of research, but the results of research have not been widely used to public or community. Common research also encourage university downstream research result, and also already launched permanent research dictee 42 concerning measurement and termination of technology readiness for helping the researcher to know how the level their research. The problem is should be able to deliver the public and business. Next. Yeah. Universities focus on the barrier to technology transfer process. Next slide, please. Next slide, please. Next slide. Yeah. Universities should focus on barrier to technology transfer process. Innovation products are not only in the form of technology, but also software, system, and even policies. All them must have an impact on society, includes general user, government, agency, or industry. High dynamic in the field of research technology require research innovation that is oriented toward product industrialization. So the downstream process is the process bridging the research and innovation closer to the user. Next slide. Downstream research product and innovation. The various form of research and innovation are application of research and innovation technology. We construct a research, we construct a innovation, but application of research and innovation that you prepare must be to answer community problems. Second, for industrial process efficiency, an application of research innovation technology to improve quality of human life. Next slide. This is a point how to support research downstream. Mean we do the research, we join with industry, and we share our research to community, use for community. The three-party collaboration between academic, business, and government to develop downstream research. If we finish the research, we prepare invention, we prepare innovation, we go joining with industry. Three-factor integration to in contact of public-private partnership, they are academic, business, and government. After ABG program, we continue with the ABGC. That means is academic, business, government, and community. Research something that we prepare already in our university in higher education will be successful if they are in synergy with ABGC, mean our product released to community user by public. So collaboration between field and science and grid added to produce innovation, which is beneficial, good in science and technology development, as well as for industrial agreement. The commercialization or research downstream with we joining with industry should be viewed as a process transferring technology from university to industry. So at this point, universities should focus on barrier to technology transfer process. Also, the research and high education must have economic value and can be used by business and or industry. And this point also, research result in higher education are not sufficient with publication, but should be able to be distributed to the public in and the industry. Ladies and gentlemen, the audience, this is our works, TPO, TSAR, rapid test for autoimmune thyroiditis. This is our work that already at the moment in clinical trial with the Rumah Sakit Saiful Anwar and Rumah Sakit Lafayette and other clinic in Malang. Now, if we have a research, we must joining with industry. Next slide. And we release our product to community. Next slide, please. Next slide, please. Autoimmune thyroiditis, where we choose a rapid test for autoimmune thyroiditis. Autoimmune thyroiditis is a thyroid disorder common in women reproductive age, a disorder with the immune system turns against the body on tissue. This is a woman with reproductive age maybe have hypothyroid and hyperthyroid. Two kind of diseases are asymptomatic, so we must diagnosis because this disease is they are repeat abortus, premature, low birth weight, and low IQ. So in this AITD, their mortality, morbidity in pregnant women and fetus is so high. So our group will be trying to produce the rapid test to stop in the faster screening diseases, because in the other rapid test or any diagnostic that already in the community is expansion, inspection fee and lab availability. So we do research rapid test based on TFOO, TSHR, based on recombinant protein. They are rapid tests that are practical, economic, sensitive, and specific. The thyroid, next slide. The thyroid hormone imbalance during pregnancy can increase morbidity and mortality in the mother and fetus and neonate. There is repeat abortion, as I mentioned before, decreased IQ development. The children after some of the fetal maternity complication reported due imbalance of maternal thyroid hormone during pregnancy. If the diagnosis late after the age of 1 or 3 months, can reduce IQ score plus 85 as much as 17% Late diagnosis as a 3 until 6 months can reduce IQ score plus 87 as much as 19%. But if the late diagnostic, the S of plus 3 months, 6 months can reduce score as much 0. It means this is a great problem. The congenital hypothyroidism screening before it's too late, ladies and gentlemen. Then you use T4 and TSH. The presence of this antibody have potential to be used a marker for early phase AITD. So we use TPO and TSHR. We prepare recombinant protein for human, and we use for detecting early phase of autoimmune thyroiditis. Next slide. Why TPO and TSHR autoantibody? Because in autoimmune diseases, the TPO and TSHR is a self molecule in the body, but because they are disorder for immune system, the TPO and TSHR respond as not self, mean the body produce autoantibody. So TPO and TSHR antibody underlie the initial inflammatory response thyroid tissue parenchymal damage in AITD. Anti-TPO, TSHR, and autoantibody can be used as a marker for detecting their autoimmune thyroiditis. Ladies and gentlemen, anti-TPO antibodies are found in 19% of patients with autoimmune hypothyroidism and Graves' disease. Ladies and gentlemen, hypothyroidism and hyperthyroidism have no sign. Next slide. For having rapid test or for having product that easily go to community, as we are in Faculty of Science, we common with basic research and applied research, prototype development, small scale production, medium large, and go to business. The question is how derive research result, and to bring researcher to industry closer together. The current focus should be research is not only basic research, but should be continue to applied research, develop downstream, and commercialization. Ladies and gentlemen, how to manage our research until technology application? The first is scientific discovery, followed by invention, followed by construct innovation, and technology application used for the community. For the first scientific discovery, this is our rapid test, our product that at the moment is in phase of clinical trial with SSR. This is our product. This is also the several technique that we can produce recombinant human TPO and TSHR for detecting autoantibody both TPO and TSHR in human. And then this is our result. We have protein recombinant, and we tested by several techniques. We purified the recombinant protein. We tested by immunodot plotting, and we purified by any kind of technique. We have recombinant protein both TPO TSHR. We tested by immunoblotting using Western blot. This is a general technique. And also we try to confirm as the autoantibody or the protein recombinant is coated in the membrane that will prepare for rapid test detection. Ladies and gentlemen, they are how interpret our it is the one line in control line, namely is normal condition, is two line in control line and T2 as a TSHR, mainly is hyperthyroid patient. Is two line also, but in control line and T1 line is hypothyroid. And is three line both in T2, T1, and control line. This is a patient with hypothyroid cases after hypothyroidism. Ladies and gentlemen, hypothyroid and hypothyroidism no sign anymore in the first phase of disease. So if the result invalid, mean the one is no line for T2, T1, and control line, or two line in T2, T1, one line in T2 on one and T1, mean is invalid. This is our preparation producing rapid test in our laboratory. After we have scientific discovery, we must dissemination the research result. We have dissemination, we have many topic for disseminate our research. Next slide. Yeah. Next slide. And the after next slide. Okay. After we have scientific discovery, we prepare invention. Mean we must construct the Indonesian patent or international patent before you going to industry. After we have Indonesian patent, we have invention. Because we produce rapid test for human. So there are many pathways for translation our research into healthcare improvement. There are first gap in translation and two gap in translation. We try to have basic research, we construct prototype research, we try to preclinical development, early clinical trial, late clinical trial, and health technology assessment. After the two gap that we must try to have is health technology assessment, health services research, knowledge management, and healthcare delivery. That our research at this point is used for the community. This is a form idea to product. They are our product with our team for detecting any kind of diseases. We are diabetic, hypothyroid, and hyperthyroid, and we joining with the Pusvetma, Pusat Veterinary Pharma, for producing vaccine rabies. The first is booster with 6 months. After we collaborated, we enhance the quality of vaccine, booster for 2 years. And also we prepare African swine fever vaccine with Pusvetma, and we have we prepare progress kit with funded by BRIN. This is a product launch, product released by community by Directorate General of Livestock and Animal Health, ASF, Asian Swine Fever Vaccine, and plasma convalescent, and also rapid detection. The second, we enhance rabies vaccine. The conclusion, ladies and gentlemen, is research in the main motor for the Bruce invention and innovation, which then have impact increasing the nation competitiveness. The commercialization of research downstream should be viewed as a process transferring technology. We need time from university to industry. The two, based on our research, autoimmune thyroid disease is a result of complex interaction between genetic and environmental factor. We try with the medicine, we try with the laboratory medicine, so on. And 3, the sooner get diagnosis for AITT that we construct, that we produce on our innovation TPO and TSHR, the sooner can start receiving treatment. This is our team. Next slide. This is our team. Prof. Joko, Dr. Rudi, Pak Agung, Bu Asih, Dr. Zul, JB, and the Bio Pharma team, Pak Diki, Bu Teki, and Pak Dedi. Thank you. This is a support the research and product supported by Universitas Brawijaya, LPDP, and Bio Pharma. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, for the next speaker, we will have Dr. Chairotri Sapsantor from King Mongkut University of Technology, Thonburi. Dr. Chairot, can you hear me?
Yes.
You
Yes.
already in Zoom meeting?
Yes. Can you hear me?
Yes, we can hear your voice clearly. Okay, before Dr. Chairot begins, we would like to share the short CV from Dr. Chairot. Operator, please. Okay, now we will have slide. Oh, this one. Okay, this one is alright actually. Maybe I will read the presentation title first. The presentation title from Dr. Chairot will be particulate matter phyto remediation by perennis plants, suitable species, stress response and application. This is the personal curriculum vitae from Dr. Chairot Sapsantor. So he obtained his PhD in biotechnology from School of Bioresource and Technology, King Mongkut University and Technology, Thonburi, in Thailand. From the BSc, he obtained from Faculty of Science and Technology, Thammasat University. Now for the position that he has in King Mongkut University of Technology, we can scroll down. This is the work experience maybe from Dr. Chairot. So from 2020, 2021, until currently, He is now associate professor in School of Bioresources and Technology, King Mongkut University and Technology, Danbury. For his research interests, he specialized in plant science, environmental science, air phytoremediation, biofiltration adsorption, plant stress, and plant microbe interaction. And there are a lot of publication from Dr. Chairot in Scopus High reputable journals, Scopus Q1 and Q2. And his index currently is now 14. And this is some of the publication from Dr. Chairot. And we actually met 2 years ago, right, Dr. Chairot? 2019 in
Yeah.
your university. Yes,
Yeah.
I visited you. Maybe next time you can visit us again in Indonesia, hopefully.
Yeah.
Okay. Now maybe we can your presentation. We can now talk. Do you want to share screen by yourself? Okay.
So, okay, can everyone see my screen, right?
Yes, we can see it clearly.
Okay, Salam Alaikum and good morning from Thailand. So, first of all, I would like to thank for the 10 basics SAI International Conference to invite me as a keynote speaker. And today I am going to talk about to share my research about the particulate matter phytoremediation by perennial plants. Actually, in Thailand nowadays, our presidents would like to move Thailand to the green Bangkok cities. That we need a lot of research to support our development as a Bangkok green cities. And actually in Thailand nowadays, especially in winters, there is a lot of particulate matter contaminate in the air that can be flow from many countries around the world and then come to accumulate in the Bangkok and in the north of Thailand. And actually the government try to spray some water in order to reduce the contaminants of the particulate matter in the air. However, the spray of the water, sometimes the drop is too large. And when it's too large, it cannot attach to the particulate matter, as you can see here in the photo. And in fact, even heavy rain sometimes, the particulate matter contaminating the air doesn't reduce, even there is some heavy rain on that areas. And also you could see that if you need this technology really, you need to reduce the size of the drop of the water to be very small. That will be cost expensive also. We are discussing about the air phytoremediation that all around the world have many research support talking about to develop some green belt or some green area to reduce the particulate matter or accumulate the carbon dioxide. So it starts in America by support by NASA. So they screen them own plants and then they found that so many species of plant can reduce the air pollution. And also some research were done in the Australia also by very big group of the researchers. And also many plants were screened in China. And we are thinking how about Thailand and in tropical zone, which we have the different species of plants. So we also start screening the plants and most of them, they are using the ornamental plant and only a few people are talking about the perennial plants. So this is the clean Bangkok as I informed to you. So nowadays the president would like to build up the green cities. However, the green city need to have some benefit also. Like the plant can also reduce high particulate matter for the well-being of the people in Bangkok and also for tourists if you would like to come to Thailand. How can plants reduce the air pollution? As you can see from here, I can conclude to you for the 5 mechanisms. So the first, because the plant have the cuticular wax or some trichome on their surface of the leaf. So it's also possible that some particulate matter can be tap or fixed by the leaf by the cuticula or some wax cover on the leaf. And also some particulate matter, if it's very small like PM1 or PM2.5, it can penetrate into the leaf via the stomata. And also we know that the plant itself also evaporates some water, and then those water have the very small particle of the water can also capture the PM on the air. And also if you have the high density of the leaf like this, when the air or particulate matter fall into the green area, then the velocity of the wind is reduced. In this case, it is gonna accelerate the drop of the particulate matters from the air to the ground. And also, actually, we could not compare this technology to the like filter technology or some other technologies. Is because this technology, I know, using the plant to tap or reduce the particulate matters is very slow. But if we compare in sustainable or sustainability is gonna be better than other technologies, because other technology maybe you need to use high energy to support. For example, if you use filter, you need the support by plug the filter to the electricity support, and also it's gonna generate carbon somehow for that process. So using the plant gonna be good also because the plant also can detoxify the toxic, not just take up or just tap the particulate matter or volatile organic compound, but plant itself have some enzyme to reduce the toxic from those contaminants. My project to serve for the government to build up the green area in Bangkok. So the first we looking for the species of the perennial plant that is good for PM 2.5 removal. And also we would like to study the patterns. How can we create the good patterns in order to reduce the highest efficiency? And also we study the plant state response in order to know how can we taking care our plants under state conditions. So at first, we throwing the plant into the testing chambers here, and also we pump the cigarette smoke, and then create around like 500 microgram per cubic meter. This concentration is the concentration that we found the contaminate real in the north of Thailand. And then we found that these 3 species is the best species for the particulate matter removals, includes all like PM1, PM2.5, and PM10. And also we conduct more experiments for more plant species. And when we found a lot of plants in Bangkok or in Thailand, we can, the plant can remove quite high % PM removal. And then from those 3 species, I think Indonesia also have this species. So this is the priorities or the good species that we select for the next experiment. We not just to show the species of the plant, but then we would like to know that if which pattern of the plant or which physiology or morphology of the plants that appears and is gonna increase the efficiency of the phytoremediation of the particulate matters. So we also study the stomata and then trichome and then the root nets of the leaf or venation of the leaf, and also we would like to see the size of the leaf and so on. And then we try to create the linear ligation to try to study the relationships between the efficiency and morphology appearance of the plants. And then we found that the plant gonna accumulate a lot of PM during night and during daytime if the plant contain the trichome or the high trichome densities, and also some stomata that is necessary for the plant to uptake the PM. This is the diacritic stomata, and also the vein numbers is also related to the PM 2.5 removal efficiency. So if you don't have those 5 good species, you may need to take a look that your plant have dichome or the good venations of the leaf or not. We also study the response of the plants. So the stomata conductance will be reduced after the plant exposed to the particulate matter significantly. You can see from here, like the correlation metrics show in negative numbers. So it means that when plant exposed to the particulate matter, then the plant try to close their own stomata, and then the plant also try to accumulate the water into their stem, like you can see from the correlation metrics that show in positive numbers. We also send our sample, the 3 good species that we found from previous experiments, we send to continue by proteomics. So you can see that the first 3 columns gonna show the normal plant species proteins. And then after that, the column number 4, 5, and 6 show the proteins appearance in the plant exposed to the PM. You can see that the first 3 and the last 3 columns show very significant difference. So it means that there is so many proteins change after the plant exposed to the particulate matter. So this we try to use the Venn Euler to categorize the unique protein, and then we found that there is some protein that appear only when the plant exposed to the particulate matter, but that didn't appear when the plant doesn't expose to the particulate matter. And most of the protein that difference in this case respond on the cell process and metabolic process, as you can see from this pie chart. And I also conclude to you in this slide. So normally in each plant have their own individual response. So you can see from here, there is up and down regulate. So you can see the arrow going up, it means that the plant up regulate, the protein relate to those things. But then the arrow down refer to the protein down regulate under those under PM conditions. So you can see here, like in perennial plant, these 3 species also have different response. But what I can conclude is that when the plants in perennial plant exposed to the particulate matters, it seems like all of them increase the antioxidant enzymes to protect their own from the particulate matter state. And also the plant gonna increase the photorespirations. So in this case, it seems like the plant try to increase the energy by increase the ATP and digest their own the glucose. So this necessary for the antioxidants work. So it seems like the plants and also plant try to close the stomata. In this case, it seemed like plant understood that at that daytime is the nighttime. So they misunderstand the plants, they confuse. And also finally, we would like to create the green belt, and then we study many patterns of the plants. How can we grow and then increase the efficiency? So we design so many designs here, and then we found that there is so many patterns that we have done. So we use this plant with this plant, or with this plant with this plant in each line, and each tall of each species of the plant. So you can see here. Okay, you can see like the best efficiency that can protect PM 2.5 is the condition that you create 2 or 3 layers of the plant. So you set, for example, if you grow this species of plant, the tall is 1.2 meters, and then another layer, you grow this plant species with 3 meter layers. So in this condition, you're gonna, in this case, the particulate matter can be reduced around 40%. And then this is a simulation that how can the wind flow. If the wind flow from the load path to the layer of the plant, then the wind velocity will be reduced significantly. And then in this case, can be explained that how can the plants reduce the particulate matters in the air. So in conclusion for my talks is about I cover all three things that the government need to create the Bangkok green cities. So the first, we screen the suitable plant species. We try to study the response of the plants under particulate matters and also mechanism of the plant to tap or to reduce the particulate matter. And also which we grow in each many patterns of the plants. And then we try to investigate the base patterns and then suggest to the government to create the good pattern for Bangkok green cities that can reduce the particulate matter around 20 to 50%. I would like to thank to my teams in Thailand for the remediation laboratory, and I would like to thank for the invitation from the BaSiC Science International Conference. Thank you very much for everyone. Thank you.
Thank you very much for Dr. Jaira Trisopsanton for your presentation. Before we move on to our next speaker, I would like to remind to all of participants of BaSiC, if you have questions to our speakers, please you can deliver your questions in the discussion session. We will have discussion session at the end of our last speaker. For the next speaker, we will have Associate Professor Dr. Muhammad Nazri Saleh from UPM, Malaysia. Dr. Nazri Saleh, are you already in the Zoom meeting?
Yes, I am.
Okay, thank you. How are you today?
I'm fine, thank you.
Thank you. Okay, before Dr. Nazri Saleh begin his presentation, we would like to display his short CV. This is curriculum vitae from Muhammad Nazri Saleh, PhD. He is an associate professor in Department of Forest Science and Biodiversity, Faculty of Forestry and Environment, University Putra Malaysia in Malaysia. His field of expertise are plant taxonomy, forest botany and ecology, forest management and conservation. And there are some work experiences that quite a lot here, but currently he is a lecturer in Faculty of Forestry in UPM from 2006 until present. For the subject, this is for the subject that he taught in the faculty, forest botany, hydrology of non-dipterocarps, and advanced forest management. So for his research profiles, there is also the profiles from his ORCID ID. His Corpus Index is currently 10, and also his Google Scholar currently is index 14. And for the educational background, maybe you can scroll up. For the PhD, he obtained his PhD from scroll down here. Edinburgh, I think. Maybe from BSc first. BSc from Conservation, Biology, and Ecology from University Kebangsaan Malaysia. And then MSc he obtained from University Kebangsaan Malaysia. And for his PhD, he obtained from University of Edinburgh and Royal Botanic Gardens, Edinburgh, UK. Okay, Dr. Nazri Saleh, Edinburgh. Yes, okay. So maybe we can now start to begin to listening for the presentation of Dr. Nazri Saleh. Do you want to share your own screen or we can help you?
Yes, please. I would like to share my screen.
Okay, yes. His presentation title is The Importance of Being a Traditionalist in the Post-Molecular Era for the Study of Diversity of Wild Mangosteen. So we have this fruit in Indonesia. Okay, thank you. Okay, now Dr. Nazri Saleh, time and screen are yours.
Thank you very much, Madam Chairman. Assalamualaikum, very good morning for all the participants and my fellow presenter. First of all, I would like thanks to the organizing committee for inviting me as a speaker today. And the topic that I want to share with everybody is about this how the importance of being a traditionalist. So the reason why I'm presenting it because the theme and the title of the conference is BaSiC. So I think we should look at the basics thing when we study, in particular of my research subject, mangosteen, and of course in the general way, when we study molecular, we need to look at the BaSiC first. Yeah, right. First of all, let me introduce you. I think everybody in Southeast Asia, if our friends from Australia, probably they also know the mangosteen. So mangosteen is a group of tropical plant, belong to family of Drusiaceae, or maybe some other people would know them as a guttiferae. This is an old name before the lineage sign. So basically, mangosteen is a shrub to wild mangosteen is a shrub to medium-sized tree, and of course, it very, very important in Thailand, Indonesia, even in Malaysia, and some tree also were planted in Australia and America, the mangosteen. So in natural forest, the Garcinia or wild mangosteen can be found from the coastal and mountain forest, and most importantly, that we should know that all Garcinia are dioecious species, meaning to say that the male and female on a different trees. Well, it was estimated that the number of species of mangosteen about 240 species in tropical forest, and of course in Malaysia maybe about 40 species, and more species in Indonesia. And please forgive me, I do not know the exact number in Indonesia species. And I know everybody know this mangosteen. Okay, it's a very famous fruit, and I think most of the English literature will quote them as a queen of fruit. The reason why the queen of fruit, because there are no male mangosteen. But this is very interesting topic that I will talk more on this mangosteen. Yeah, right. Other than mangosteen, there are many other species in the wild that you can find. For example, this is Garcinia nigrolineata, okay, Garcinia griffithii, and Garcinia mengai. They are all edible species. You can eat them. Okay, directly. Of course, if you have to wait the fruit until you're ripe. Anyway, when we talk about the post-molecular era, in classification or in plant taxonomy or in botany itself, we know that the classification have changed a lot. Before the era of theory of evolution by the Darwinian, people always try to differentiate things based on what they saw, based on the morphology, and based, of course, during the old time, they're based on whatever people or learned people say. And there's no such thing about the phylogeny, no such thing about the evolution. But after the post-Darwinian era, we say all other classification based on evolutionary processes, meaning to say that every single life form in the world, we have to study the phylogeny and relationship with other organisms or with other species. And then we can differentiate them, and then we can classify, and then we name them. Actually, the time frame here, 1993 and after 93 is not really exact, but this is more or less what we call as a pre-molecular era, because this is before the 1993. Most of the classification of the research were done based on whatever morphology that they saw from the shape, flower, and everything, and of course under the microscope. But after the molecular have been used in classification, all or not all, but more research are based on the genetic-based phylogeny. And after 1995, there are many others, what we call as a molecular phylogenetic study or base. So classification now become more or less separated into two group of researchers. Some of the researchers would like to use all the molecular data using the DNA and everything. Others using both molecular and morphology. But actually, this is nothing wrong to do with it. But in this topic, I would like to stress on this, the traditional on this taxonomy part. Okay. In the traditional study, we use in molecular or in plant. I'm just talking about plant classification. I would not touch about animal classification. We use herbarium specimen. Yeah? Herbarium specimen. That is the most basic thing. If you want to classify, you want to know the species, this is the most important thing. We use herbarium specimen. I think Botanic Garden has one of from this herbarium specimen. We use also classical or what we call as a manuscript, or in other words, we call them as a protolog. In other flora that have been published since the beginning of the research, for example, this is a publication produced by the Rumphius in 1741, but of course in the Dutch and also in the Dutch and in Latin, and of course they translate in Latin, and also with some other thing, especially the morphological part. And we have to go to the forest. This is a traditional study. Okay, this is what we call a traditional study in plant taxonomy. But with the advance of the advance of the molecular technique, there are many people have jumped into this search of plant diversity using many methods. There are RFPD, RFLP, AFLP, and then the next thing, you know, you're using SCAR, and many other people using next-gen sequencing, ISSR, and some other people with much more money, they use just transcriptomic, proteomic, metabolomics. And above all, the DNA barcoding become mostly quite popular for plant classification and plant identification, which I don't think it is wrong, but we have to consider about the classical or traditional taxonomy. And because of the advance in molecular, because of this Darwin theory, there are groups that call themselves the angiosperm phylogeny group, and they produce a new classification. Traditionally, we use a very old system like a Bentham and Hooker, but now they're using APG. Now APG classification at this stage of 4, which is actually produced in 2016, there's no new classification, but they're advancing and they're progressing well. And for the family of Clusiaceae or Gutiferae, then because of this APG, they are separated into 3 families. One is Clusiaceae, the original one, and the other one is Scalophyllaceae, and the other one is Hypericaceae. This is the impact of the APG group, which I think everybody in plant taxonomy, I think very much into this, and they are really using this APG classification. Anyway, if you're interested to see the APG, you can go into Missouri Botanical Garden website, mobot.org. This is the angiosperm phylogenetic group. So basically, all of the families, all of the group are connected with each other using this phylogenetic tree. Now, let's talk a bit about Clusiaceae because of, well, like I say, the family has been separated into 3 families: Hypericaceae, Scalophyllaceae, and Clusiaceae. Yeah, and of course, this is actually paper produced by Raffel in 2018. And then this is again by Sweeney study using the ITS and GBSSI dataset using molecular data, of course. They're producing another phylogenetic tree. This is about the relationship in or phylogeny in genus Garcinia itself. So I'm not going to talk more into that. And from my study, that was a long time ago, when I did my PhD, I'm using both traditional and molecular. But most of all, I would use traditional taxonomy. I'm using herbarium. I'm visiting I'm using the herbaria in Bogor, herbaria in Kew Garden, herbaria in Leiden. Every single herbarium that important, I already visited them. So based on that, I produced 2 new species in Peninsular Malaysia, and I reduced the number of section Garcinia from 45 to 16. This is section, and I got many synonyms, and even in that research, I found there are many illegitimate use of name, and then 9 species were omitted from this section of the Garcinia. And of course, there also when we study, sometimes we could not solve the problem, and from that I found that 5 unknown species because of lack of material. So, little bit on historic manuscript of Garcinia. This is the Garcinia actually born out from the publication of Linnaeus in 1753, when Linnaeus got the material sent by Louis Garcin, and he named the specimen as a Garcinia because of the name of the collector that sent the material to Linnaeus. And this is also based on the fruit tree of Garcinia magosana, which most likely the origin of the specimen might be from Southeast Asia. And then later on, the number of species increased, and one of the reasons because of the publication of this Herbarium amboinensis, which is produced by the Rumphius. Of course, I think Indonesian who study plant taxonomy know Rumphius. He's a Dutch, and he published quite a lot of number of species. 2 of them was Garcinia celebica and Garcinia cornea. So again, as the time goes, the number of species become increased. A lot more species being discovered in other part of the world. Okay, for example, in Java, in Sumatra, and even in Peninsular Malaysia, and even in India and Sri Lanka, Flora British India, Flora Peninsular Malaysia. This is all this published by the colonial. Right. From my study, I found that when I searched all the document, when I see all the herbarium specimen, I found out that there are some very peculiar things, because at different part of the world, there are many samples, many specimens, and even trees that were planted in the Botanic Garden of Bogor, in Malaysia, and even in Sri Lanka. Actually, it's similar species, but the name was different. This depending on the author. For example, celebica, there was earlier published, like I say, in Sulawesi Island, was named by Rumphius, and then of course adopted by the Linnaeus, named as Garcinia celebica and Garcinia cornea in Maluku Island. And of course, when British came to Peninsular Malaysia, they found similar species. They call it as Garcinia humbroniana. And of course, in Borneo Island, Garcinia Kerawang, in Bangka Island, Garcinia Rumpi, Garcinia Jawaera, Fabrilis, and so on, including Garcinia kingiai, Kuziai in the Andaman Island. So, because of that, okay, before that, this is actually a picture of this Garcinia celebica and Garcinia cornea by Rumphius in 1741 in his Herbarium of Amboinense. Okay, 2 different pictures. The reason why there are 2 different pictures, because actually what happened, Rumphius already published or at that time they don't have a publication, mass publication. He published his book, but the book when this was sent to Dutch, if I'm not mistaken, there's something actually disaster happened and the ship was destroyed by the fire and the book was lost. And at the same time, Rumphius, when heard that, he becomes sick. Not because of that, it became because of other thing, and he became blind. So he altered another book, and the drawing is drawn by other, not by himself, but other people based on his description. So this is why look very not very, but there are actually differences between those two pictures here. But actually, those two, the one that found in Sulawesi and the one that found in Ambon, is a similar tree and similar species. And of course, this is the character white latex, yellow latex, that description in his book, flower in tree, flower in two. But when I study the tree, when I study the sample, I found out that those both are similar species. And again, because of that, I'm uniting all the species that I mentioned before, the long list of sample into one single species as a Garcinia celebica, because Garcinia celebica is the earliest name that was published by Linnaeus by way of Rumphius publication. So this is why we need to study traditional taxonomy. If we do not have this kind of information, we just do molecular work, there will be other result that will come up. But I myself do not really hate molecular, but I use molecular as a support data, as a tool for my study. And when I study the sequence of the ITS, I just take a little part from the nuclear rhizomal DNA, sequence them, and build out phylogenetic tree. I found that what I found in in taxonomic data from the books, from the observation, from the morphological data, fit in with the molecular or DNA sequences. So if you can see this part, the upper part of this clade of phylogenetic tree, all of this supported by the very strong support that lump together all the name that I told you into one single cluster. Of course, this is celebica. I already changed it to celebica. This is in Vietnam, Java, Thailand, Kalimantan, Thailand again, and Sulawesi, and other part. And they all fit in. So meaning to say that what I did was correct. And based on specimen herbarium also, when I study more specimen, I found out they all share the similar character, which is what I call, this is similar, the character that define the species, which is stamen in 4 bundle, fruit solitary, and position in terminal branches, and female also solitary, and male in a cluster of 2 to 10 flowers. So that's one thing. The other thing that I did was to see the origin of the mangosteen theory. The origin of mangosteen theory was published by Richards, researcher in Newcastle University, P.W. Richard, who studied, who actually the first who said that mangosteen is originated from 2 different species, hybrid between 2 different species, which is Garcinia celebica, which previously known as Garcinia brunena, that he found in Peninsular Malaysia, and Garcinia malacensis. So again, this is by Richard when he studied the chromosome and the morphology. And other people also try to study the origin of mangosteen just by using the DNA. This is one of the researcher from who study Garcinia in Southeast Asia. The paper was published anyway in 2012. I think it's from Thailand. Okay, he did collect a specimen from Bogor Botanic Garden, and he included in his study. Oh, sorry. Let me see. Okay, this is the one. Yeah, from Botanic Garden in Singapore. Sorry, in Botanic Garden in Bogor, and in some sample collected from southern Thailand and Peninsular Malaysia. So he found out what Richard earlier said, Malacensis and Mangostana. in similar group, but also other species which he collected from Bogor Botanic Garden, including Garcinia rostrata, speciosa, and Zizifolia. And of course, Garcinia morena he collected from southern Thailand. And the other one, of course, my friend from Newcastle University, he just collected from sample from Peninsular Malaysia, Garcinia opaca, and Garcinia morena. And again, because of that, this result from the molecular sequences, they say that there are many other potential parents of Garcinia mangostana or mangosteen. So it become more complex. Earlier, like I said, Richard only said 2 hybrid species, but now they include more and more species as a potential parent. However, when I study the morphology, I study morphology of the Garcinia malacensis. I study the morphology of the mangosteen. I went into the forest. I explored. I went to Indonesia. I went to Malaysia. I found out Garcinia malacensis actually is kind of a wild species of mangosteen. The taste is similar, and the shape a little bit different. This is a Garcinia Garcinia malacensis, and these two B and C Garcinia malacensis. This is another Garcinia pinangiana. This is closest relative, and this is mangosteen. So with this kind of thing, I think. So I produced a paper. I said that the origin and evidence based on morphology and ITS sequence that Garcinia actually came from the wild mangosteen species. So what I did was I uniting both species, Garcinia malacensis into Garcinia mangostana, become a variety. The first one is Garcinia mangostana variety mangostana. The second one is Garcinia mangostana variety malacensis. So the study is still ongoing because my student is trying to using the next-gen sequencing to prove the theory. And when I did also only just a fraction of the nuclear DNA, so might be not very strong enough. So my student continued the study. And from the phylogenetic tree, this is what I got. This is Garcinia pinangiana that shown earlier, and the whole group of Garcinia mangostana and Garcinia malacensis is seen within same group, and they're intermixture. And because of that, I just combining those 2 species into one species. So because of that, that is what I said is the very important thing. If you want to study molecular, want to study DNA, go back to BaSiC first. Don't just jump into DNA study, molecular study, and then you make some assumption, which the next few years, somebody will refute you, somebody will prove that your study is wrong. And because of that, you only have a regret later on. So in conclusion, I would say, in any diversity-based study, the traditional method using herbarium specimen, historical book, and finding evidence is very, very, very important. And modern technique, by any means, even though they are necessary, should be done appropriately. And if you want to draw a conclusion, you need to have some reservation. And for that, I would like to thank the organizer for inviting me today. I'm very happy to answer any question from all the audience. Thank you very much.
Thank you, Dr. Nazri Saleh, for your presentation. Now we begin our discussion session. Okay, for the next one, I will like to invite to one of you, if you are at home using Zoom online, from the participant that is connecting using their Zoom online. If you have any question for Ibu Professor Aulani Am first, you can ask your question directly. So I would like to invite to all of you if you have question for Professor Dr. Aulani Am first. From the one that joins using Zoom meeting online. Okay, maybe we move on to the one here in the ballroom. If you have any question for Ibu Professor Dr. Aulani Am for her presentation. Okay, maybe I would like to ask first to Professor Dr. Aulani Am. Well, because you talk a lot about the heat detection for autoimmune thyroid disease. So for autoimmune thyroid disease detection in a kid or for kid for that disease, is there any minimum age for us, maybe for people that use the kit, or only this kit for adults, not for children?
Okay, thank you, Anna, for your question. The autoimmune thyroiditis is a disease no have sign in the first phase of diseases. The test used for men have history of hypothyroid on or hypothyroid, and also used for women, pregnant women, for evaluated that have a congenital hypothyroid for her babies, and also for babies can use this kit to find out congenital both hypo and hypothyroiditis, because in the we have information that is someone late diagnostic for babies that have a congenital hypothyroidism, the age of 1 or 3 months, can reduce the score next year score plus 85 up to 78%. So this test is for every age of for babies, for women and pregnant women, or for men, also for men that have history of hypo and hyperthyroidism in the family.
Okay, thank you so much for your answer. So this kit is for all age, from babies until elderly, maybe like that?
Yeah.
For any kind of sex, female, male?
Yeah.
Oh,
Yeah,
okay, so this is
female.
for
Yeah.
the whole the wide variety of age and also for male and female. Okay, maybe we move on to our next speaker, Associate Professor Dr. Chairot Trisop Santon from KMUTT. Is there any question for Dr. Chairot? Dr. Chairot, are you still joining with us in the Zoom?
Yes, yes. You can
Okay,
hear my voice, right?
yes, we can hear it. Okay, is there anyone in the Zoom meeting would like to ask question for Dr. Chairot? Maybe in here, in on-site location? Okay, Dr. Herwin. We have one question, Dr. Chairot,
Okay.
for you. I hope you can hear.
Okay, thank you very much for the opportunity. I'm very interested in your explanation about the species that can be used to reduce the particulate matter, right? So my questions is, besides the species can be used to reduce the particulate matter in the air, can we also use that species, I mean the plants, to reduce the noise maybe that could be occur beside the particulate matter? Because I'm just studying about the environmental physics, and we also learn that besides the air pollutions, we also have a problem with the noise. So I'm just wondering if we also can use the specific plants to not only reduce the particulate matter, but also the noise. It's like a damping the noise. Thank you.
Okay, so actually what I know is that the plants can the density of the leaf gonna change the so many pattern of the airflow, and also I believe that the plants can also reduce the noise as you said. However, I still didn't see that many publication talking about this, but it's interesting. Actually plant, I know the plant can reduce the temperatures very well, and also can reduce the carbon dioxide and also air pollution and volatile organic compounds. But for the noise, I think it's very good if we can start thinking to study this. But what I think, I believe that the plant can reduce the noise also.
Okay, Ibu Herwin, are you happy with the answer? Okay, thank you so much, Dr. Jairat, for your answer. Now we move on to our last speaker in this session, Muhammad Nazri Saleh, Dr. Muhammad Nazri Saleh. So for all participants in the Zoom meeting, if you have any question, please raise your hand and you can unmute your voice in the Zoom meeting. Or maybe here in our ballroom in Ijen Suites Hotel, if you have any question for Dr. Muhammad Nazri Saleh from UPM. Okay, maybe I will ask question first. So because taxonomy is actually not my research of topic, but I try to follow your presentation because we have this kind of fruit in Indonesia, mangosteen, and this fruit is quite popular in the past, but now it's hard to find this fruit in the market. So from your presentation about because you show us the phylogenetic tree, if I'm not mistaken. So when you make a comparison, the phylogenetic tree between the wild mangosteen from maybe all over the places, all over the countries, do they have the morphologically and the DNA, do they have the same similar morphologically and DNA from this wild mangosteen?
Yes, it is. Like I said earlier, the theory of mangosteen rise from the hybridization of two wild species. But what I found out, actually, the mangosteen itself is a mangosteen, meaning to say there are wild mangosteen, there are mangosteen that we commercialize. And because of that, if anybody in Indonesia, of course, if you found male tree of mangosteen, please do tell me, because I don't think you will get it, male mangosteen. Very, very rare occasion. The only male mangosteen they can find is male mangosteen that they call is something else. Male mangosteen, maybe some they will known as other species, because that species actually is what we call as a wild mangosteen, Lacina mangostana, that found in the wild. It's just only a little bit variation, morphologically similar, except that in the flower and of course the shape of the fruit. That's all. Thank you.
Do you have mangosteen quite a lot in Malaysia, or do you find it like popular in the market, fruit market, or is not really like in here?
Yeah, I think more or less we are similar. Thailand, Indonesia, and Malaysia, mangosteen is one of the best fruit ever. Okay, so the price also is quite expensive because it's only fruiting once a month, and because of the only female mangosteen that are planted, meaning to say that it's very difficult to improve the genetic all over the world, only female mangosteen. So Now with my study, we know that you can find a male mangosteen in the wild. You can improve the quality, improve the genetic from the wild mangosteen in the forest.
Okay, thank you very much for your explanation. Okay, so now, Bapak dan Ibu, ladies and gentlemen, if you don't have any more questions, I would like to conclude this plenary session in session 1. I would like to say thank you very much once again to Ibu Professor Dr. Aulani Am, Associate Professor Dr. Chaira Trisubsontorn, and Associate Professor Dr. Muhammad Nazri Saleh from Malaysia. And give a full applause to all of them. Thank you very much, and I will return this screen and time to our MC. Our host.
Thank you very much, distinguished delegates, all participants, all speakers, ladies and gentlemen. That is the end of our plenary session 1. We hope all the speakers, Professor Aul, remain to the stage because there will be the presentation of token of appreciation and also certificates for the keynote speaker. We will invite Vice Dean 1 of the Faculty of Science, Brawijaya University, to present the token of appreciation and also certificate to the keynote speaker, Professor Aulani Am. And for our online keynote speaker, the certificate will be sent by email. Please help the committee. On the stage, please. Well, thank you very much for Ibu Nurjanah, PhD, for the presentation of token of appreciation. And also thank you for our speakers and our moderator for the plenary session 1. And ladies and gentlemen, before we continue to our next session, that is plenary session 2, we please all the participants to enjoy 20 minutes coffee break. The coffee break have been prepared by the committee at the back corner of this room. We wish all participants return to the forum at 10:20 sharp. Please. Thank you very much. And while all the participants enjoy the coffee break, later I will announce that the plenary session 2, there will be Ibu Nur Sofiana, PhD, as the moderator. We also later invite to the stage our speakers, Associate Professor Karel Swatlenka from Kyoto University and also Associate Professor Dery Wijaya from Boston University, who will join online. Thank you very much.
Ladies and gentlemen, Bapak dan Ibu, we would like to begin our second plenary session. We will have two more speakers. They are Associate Professor Karel Svatlenka from Kyoto University and Associate Professor Dery Wijaya from Boston University. For the second plenary session for today, we will have Ibu Nur Sofiana, PhD, as our moderator. For Ibu Nur Sofiana, PhD, or Ibu Sofi, time and screen are yours.
Okay, thank you very much, Bu Ana. Assalamualaikum warahmatullahi wabarakatuh. Yeah, good morning, ladies and gentlemen. It is a pleasure to be here with you today. First, I would like to introduce myself. I am Nur Sofiana from Mathematics Department, Brawijaya University. In this second plenary session, I am serving as a moderator. Okay, in this session, we have two keynote speakers. The first is Associate Professor Karel Svatlenka from Kyoto University, and the second is Associate Professor Dery Wijaya from Boston University. Okay, let's start the first talk from Associate Professor Karel Svatlenka, but before it, let us show the short CV of Professor Karel Svatlenka. Yes. Yes. So Professor Karel Svatlenka graduated from Charles University in Prague, in Czech Republic, and he also got his PhD in Kanazawa University too. And the field of interest is the calculus of variation, scientific computation, mathematical modeling, and nonlinear partial differential equation, numerical analysis, and yes, mathematical modeling. And he have many contributions in that field. This is the publication track of Associate Professor Karel Svatlenka. Okay, I think it is enough for short CV from Professor Karel Svatlenka. And now let's start the talk from Associate Professor Karel Svatlenka. If you have any question during the presentation, you can write your question in column chat or ask directly in the discussion session that will be in the end of this section. Please welcome Associate Professor Karel Svatlenka. The time and screen is yours.
Okay. Dr. Sofiana, thank you very much for the thoughtful introduction, and I wish a nice morning to everyone. So first of all, I would like to extend my sincere gratitude to the organizing committee for giving me the precious opportunity to participate in this stimulating BaSiC 2022 conference. Okay, so I will screen. Okay, is it okay? Okay, so today I would like to talk about a special material with the layered structure. So first I will introduce the material and the motivation for the research. Then the mathematical tool called homogenization, which is used to address the problem, and finally present results of numerical simulations in comparison with experiment. Okay, so in this talk, I would like to focus on structured composite materials. So such materials are composed of two or more different types of components that are arranged in a regular geometrical structure. For example, as shown in this picture above, one material may be included in the other in the form of spherical particles or fibers, or both materials repeat in periodic laminate layers. So the interesting question now is, given the material properties of the components, what happens with the properties of the whole composite material when the scale of the structure is made finer and finer?
I'm sorry.
Yes.
Professor Carol, the slide still not move, still in the first page. Is it correct?
Oh, really? No. On my screen, okay.
Mhm.
So I will. Sorry, I will. Okay, so I don't. Now, can you see the outline? Or
No, this is still in the first page. I mean the cover.
okay, so I will. So I will use not the full screen mode. Now you can see, right?
Yes.
Outline.
Yes.
So
Okay.
I will not use the full screen mode because it does not work. Okay, sorry. So yeah, I talked about this slide. Sorry for the problems. So now, yeah, we are interested in the limit when the particles or fibers become smaller and smaller. So it turns out that the limit material may have very interesting properties, and when the structure and material properties of the components are chosen in a clever way, the resulting material may be designed so that it has desired excellent properties. And that is why there is a lot of effort put into studying such materials. So to give an example, by combining a very soft and very hard material into a pattern like in this picture below on the left, one can achieve negative Poisson ratio for the composite material. This means that the material expands when stretched, contrary to most common materials. Another example is a composite material with negative thermal expansion coefficient, which shrinks upon being heated. Okay. So this study was motivated by a special magnesium alloy which was developed in Japan in Kumamoto University, and which shows similar magical properties as the materials mentioned in the previous slide. So this alloy is obtained by mixing pure magnesium with two other elements, one transition metal such as cobalt, nickel, copper, zinc, aluminum, and one rare earth metal such as yttrium, samarium, gadolinium, terbium, and so on. So this results in the formation of a layered periodic structure with layers of pure magnesium and layers containing clusters of the additive elements. So the additive element clusters are strongly bonded and concentrated in layers, and these strongly bonded layers and weakly bonded layers of magnesium are stacked upon one another, repeating the stacking over a long period, shown in the figure as one unit. So that is why the structure is called long period stacking ordered, or shortly LPSO. So the magic of this LPSO alloy arises when this alloy is compressed, for example, by extrusion. So compression triggers the formation of king bend structures within the LPSO structure as shown in the left figure. So this in turn leads to a dramatical increase in the yield strength of the alloy. So magnesium is actually a very attractive metal because it is light, cheap, and has many other good properties. But it has one disadvantage, and it is a low mechanical strength. Therefore, the possibility of strengthening it through kinks in the LPSO structure is very promising, and a large amount of work has been done in this direction. However, so the principle of this kind of strengthening is still not well understood theoretically. And it would be very useful to know the principle, as it could be applied to a wide range of other materials to make new outstanding materials. So my goal is to address this question from mathematical perspective by building and analyzing a suitable mathematical model. So since we are dealing with metals, the model should take into account plastic and also elastic behavior of the material. However, if we try to resolve the individual layers, the problem will be too complex from both theoretical and numerical viewpoints. So the idea is to consider the limit as the width of the layers converges to 0. So this approach is called homogenization, and we will use gamma convergence as the main tool. So let us start with the stationary homogenization of layered structure, and the problem is formulated as described in this figure. So given a periodic layered structure and the elastic and plastic properties of each layer, what is the elastoplastic response of the material obtained in the 0 limit of layer width? This is the question. So to consider this kind of limit is meaningful for several reasons. So first, the homogenized problem is simpler than the layered problem, so it is easier to analyze and understand. Second, it is almost impossible to resolve the layered problem numerically because the numerical measure has to resolve each layer, but the homogenized problem is numerically solvable. And lastly, it was shown through physical experiments on many problems that the homogenized material is a good approximation of the real layered material. Okay, so the main idea how to characterize the homogenized problem is to look at the respective energies, that is to study the convergence of energy functionals. Here I present the definition of gamma convergence, which is one of the tools to do so. So functionals fk on some space, metric space X gamma converge to F infinity if these two conditions are satisfied. So lim inequality, which says that for every sequence UK converging to U, this inequality must hold. And the second one is the existence of recovery sequence. So for any U, we have to be able to find a sequence which converges to U and the energies also converge. So there are many nice properties of this gamma convergence, but probably the most important one is that it preserves the minima or infima in the limit. Yes. Okay, so it's written here, down here. Okay, so next I would like to describe the model of the material. So as in the figure, we consider a layered material occupying a bounded Lipschitz domain omega. And so here two different layers with thickness ratio lambda to 1 minus lambda are repeating periodically with period epsilon. So we use the assumption that the deformation gradient nabla U can be decomposed multiplicatively into the product of an elastic part Fe and plastic part Fp. So the deformation properties of both layers can then be formulated as follows. So for both layers, the elastic part is allowed to be only local rotation, so that Fe is always a member of the group SO2. So now about the plastic part, for the more rigid layer, shown in blue in the picture, it has no plastic deformation. So Fp is equal to identity matrix I. And the soft layer shown in yellow in the picture, the plastic glide can occur along one active slip stem given by the orthogonal unit vectors S and N with slip direction S and slip plane normal M. So that the plastic part has the form as written here, I plus gamma times S times M. Here gamma is the amount of slip. I show the meaning of the deformation I plus gamma s times m here in this auxiliary slide. So we can see it corresponds to a shear of size gamma in the direction of the vector s. Okay, so the energy of the material can be expressed as in the formula below here. That is, if the deformation gradient in each layer has the allowed form, then the energy density is the square of amount of slip of gamma. So we would like to homogenize this kind of energy, and it looks easy because it's just a quadratic function of gamma, but it's actually very difficult, quite non-standard, because it contains non-convex constraints in the form of partial differential equation inclusions. Okay. So the basis of homogenization analysis are the following two rigidity results. So the first one, dating back to 1967, states that if a Sobolev function is locally a rotation, then it must be a constant rotation globally. So it's a affine function. So this implies that the rigid layers can only undergo rigid body motion, so only rotate as a whole. And the second result, theorem 2, is due to Caroline Kreisbeck, is quite new and investigates what happens with the whole system in the zero limit of layer width. So it says that if we have a weakly converging sequence in W12, such that each member is equal to a rotation in each rigid layer, then the limit of this sequence, if it preserves volume, is composed of local horizontal shear and a global rotation. So it's equation number 1 here. So the horizontal direction E1 is in fact identical to the direction of the layers. So the homogenized material can slip only in the direction of the layers. So this, okay. So here is the main stationary homogenization result, which says that the energies of the layered structure introduced before gamma converge to the functional E given here. So the most important point here is for which kind of deformation is the energy final. So as we can expect from the asymptotic rigidity result in the previous slide, the gradient of these deformations must be horizontal shear combined with global rotation. So in addition, the magnitude of slip is at each point in the material is restricted to lie in the set K as lambda given here. Okay. So up to here, I have talked about homogenization of the stationary problem from which we can read of this instant response of the homogenized material. However, in plastic deformations, we are mainly interested in evolution problems. The well-known reason is that elastoplastic deformations are irreversible, as shown schematically in this figure. So maybe everyone knows that, but let's take the example of pulling a one-dimensional rod. So then if in the first stage from point A to B, on the stress strain curve, the deformation is purely elastic. So here it is a straight line, so the material follows linear elasticity. At point B, when sufficient internal energy is stored, the glide of dislocations is activated and plastic deformation joins the elastic one. If we stop loading the rod at point C and release the rod, then the material unloads elastically up to point D, but does not reach its original state A, leaving some amount of plastic strain. So from this, we can see that in plasticity, there is no one-to-one correspondence between stress and strain, which means that we need the information about deformation history to determine it. So there is some method to address this physically. Okay, but I will go. So to the next slide. And maybe because there was some time problem, so I will explain this only briefly. So the elastoplasticity problem can be then formulated in the framework of rate-independent systems. So there are three components of this system: the state space Q, which describes all possible states of the material, the energy functional E, and the third component is dissipation distance, which measures the minimal amount of energy that is dissipated between two given states. Okay, so we would like to have some notion of solution for this system, and it is given by this energetic solution, which satisfies these two conditions. So the first, let's say the second condition E expresses the conservation law for linear momentum. So all work put into the system by external forces or boundary conditions is spent on increasing the stored energy, or it is dissipated. And the first condition S is the requirement that the formulation must satisfy the second law of thermodynamics. So this the advantage of this formulation is that there are no derivatives in the equation, so it can be formulated on an abstract topological space Q. And another advantage is that time discretization leads to a simple numerical approach. So actually, if we solve the minimization problem on the last line and interpolate the solutions, we can show that when the time step goes to 0, the interpolated functions converge to the energetic solution. Okay, so now we would like to think about homogenizing this evolution problem, and a tool for this is called evolutionary gamma convergence. I will skip the details. If there is question, I can explain more. So here I give a definition and sufficient conditions for evolutionary gamma convergence to hold. Actually, the most difficult question is condition is number 5, which can be still restated as existence of mutual recovery sequence. Okay, so mutual means that the recovery sequence works for both energy and dissipation components. However, so there are almost no results, unfortunately, for evolutionary gamma limit of layered structures. Only a very special cases have been investigated. So the reason is that it is very difficult to construct a mutual recovery sequence. In particular, we have to deal with sequences of the type written here, R times I plus gamma E1 times E2. And we only know that R epsilon and gamma epsilon converge weakly, but we cannot say anything about the convergence of their product. So I'm now thinking about the problem in the direction of using the idea of compensated compactness to deal with this. Okay, so at the moment, we are not able to derive a general homogenized evolution model, but still we would like to do numerical simulations to see whether this approach works. So to do so, I proposed a mathematical model of rate-independent elastoplastic deformations, which takes into account all that is known, in particular the stationary homogenization result. So in this model, I take the state space Q as here, the functional of potential energy like here, and the dissipation D as here. So okay, there are several assumptions on all the terms, but I will not bother you with the details. Okay. I will only say that we can prove the existence of energetic solution to this model using the theory of Professor Mielke. Of course, we need to assume some conditions on the exponents of the Sobolev spaces and so on. Okay, so enough of theory. So let's go to the real-world applications. So to obtain some real-world data, we performed a compression experiment in the lab of physics of materials at Charles University in Prague. And the test used a custom-made experimental setup, and the testing material was just a block of paper sheets. So the block was placed on a steel plate and between two thick aluminum plates so that the sheets were parallel with the plates. So loading was applied from the top by means of a brass panel, slightly longer and narrower than the top face of the block, with constant 0.075 millimeters per second. So the video recording was performed using Panasonic camera with full HD resolution. But before that, the front side of the paper block was facing the camera was sprayed with black acrylic paint in order to create a speckle pattern for the digital image correlation analysis, or DIC analysis. And this analysis is basically a computer code which detects the motion of the speckles and calculates the displacements and strains. So let's look at the experimental results that came from the DIC analysis. I hope you can see the movie. So the movie shows the evolution of displacements in the first row and strains in the second row. So one observes the gradual formation and propagation of localized zigzag deformation bands, which are often called kinks. Okay, so here I show the obtained compression curve, which exhibits an intermittent plasticity character manifested by means of several pronounced stress drops during the loading. So a comparison with the DIC movie shows that the serration corresponds to the gradual formation of and propagation of kink bands. That is, we see that the load drops correlate with the formation of kink bands. Okay, so next, I would like to do numerical simulations to verify that the model is capable of reproducing the main features of the results obtained in the physical experiment. So for now, we adopt the 2D setting in our computations. So imitating the setup of the experiment, we take a rectangular region of material and subject it to loading through a prescribed displacement of the upper edge in the vertical direction. So the elasticity of the material is assumed to follow the Neo-Hookean model with a single slip system having glide direction 0, 1, so horizontal. So this reflects the theoretical homogenization result. And so the energy function takes the following form in the top formula. So the first two terms are the elastic energy, the last two terms are related to the plastic contribution, and the third term describes the transverse isotropy inherent to the stack of paper sheets. So in the numerical simulations, we discretize given interval, and at each time step, we need to solve the minimization problem in this box. So for spatial discretization, the rectangular region is partitioned into a regular triangular mesh, and the functional E and D are approximated using the finite element method. So in particular, we use linear P1 elements for both the position vector variable U and the scalar value slip variable gamma. So plugging these piecewise linear approximations into the energy functional, we obtain the at each time instant nonlinear function of the FEM coefficients, which has to be minimized. So the minimization is carried out using the MATLAB optimization toolbox function, which is based on trust region optimization algorithm. So I wrote the parameters here, but I will skip the details. I only mentioned that the elastic constants were chosen so that they match the at least of order of magnitude matches with experimental measured values reported in several papers on paper sheets. Okay, so let's first watch movies of simulation results. So we observe that first only purely elastic deformation happens, and when sufficient energy is stored, sudden plastic slip in the whole domain occurs. So the pattern is quite similar to the experiment. The only big difference is that in the real phenomenon, king banks are formed one by one in sequence, while the mathematical model is quasi-stationary. So all the kings appear at once as soon as sufficient energy is stored to allow for the plastic deformation. Okay, so this can be seen clearly by comparing the displacement load curves for experiment and simulation. So in experiment, there are several drops in load, but in simulation, there is only one big drop. Okay, so to compare the results more in detail, here I show both experimental results and the simulation. And experiment is on the left and simulation on the right. Both have a color bar. So both images are at the same time when the vertical displacement of upper boundary is around 12 millimeters. At this time, so in experiment at this time, the king bands just reach the lower boundary, and in simulation, it is a little after the king band structure piece in the simulation. So despite a quite simple mathematical model, surprisingly good qualitative and even quantitative agreement is reached. So to conclude, I conclude by saying that the comparison between numerical implementation of the model and experimental measurements shows that the model goes in the right direction. However, there are a lot of things to do. Mainly, we would like to know the principle of king strengthening. So to go in this direction, I would like to work on these 3 points, mainly to derive the model as evolutionary gamma limit of rate-independent system. So this is important to show that the model is physically correct, and also discover the relationship between material properties of the different layers and the homogenized material. So next goal is to perform experiments with different type of material. Actually, we plan to do that this month and do 3D simulations. And finally, I would like to understand the dynamics of gradual king appearance by using the mathematical model. Okay, thank you very much for your attention. I would like to end here. Sorry, I cannot hear. We cannot hear on Zoom.
Okay, Professor Carol, can you hear me?
Yes, now it's okay.
Okay.
Thank you.
I'm sorry. Yes, okay, thank you very much, Professor Karel Swadlenka, for the nice presentation. Now we move to the second talk from Associate Professor Dery Wijaya from Boston University. Are you there, Professor Dery?
Yes, I'm
Hi.
here.
Okay. Okay. So before the talk begin, let me show the short curriculum vitae from the Associate Professor Dr. Dery Wijaya. So the interest in natural language understanding, multilingual and multimodal representation learning, information extraction, knowledge basis, law resource, machine translation, machine learning, and data science. And Associate Professor Dery Wijaya took the bachelor and master degree in National University of Singapore School of Computing, and she took her PhD in Carnegie Mellon University Language Technical Institute School of Computer Science. And yes, there are a lot of her contribution in that field of interest. And this is the publication track we can see in the slide. Now, currently, Associate Professor Dery Wijaya is in Computer Science Department, Boston University, USA. This is the short curriculum vitae, and now let's start the talk. You have 30 minutes, Professor Dery. And for the participant, if you have maybe if you have question during the presentation, you can write in the column chat, or you can ask directly in the discussion session in the end of this plenary session. Okay, please welcome Associate Professor Dery Wijaya. The time and screen is yours.
Thank you. Good morning, everyone. So today I'm going to talk about artificial intelligence in post-pandemic world. This is because this area is very related to my research, which is on natural language processing and machine learning. Specifically, my research is on how we can build computer systems that can translate languages automatically, especially for languages that have few training data, so low resource languages. I also conducted research in media framing, particularly how we can build computer systems that can detect how media frame issues when they write about them in the news. So these two areas, natural language processing and machine learning, are subfield of artificial intelligence. And artificial intelligence become a very, maybe a buzzword because of this industrial revolution 4.0, right? So probably you heard a lot about it in the news and so on. So the industrial revolution 4.0 basically follow from the first, second, third, and then currently the revolution. So the revolution today is basically where we are trending towards automating of any traditional manufacturing processes or industrial practices. And it's also signaled by the use of data and the generation of data and how data basically can be used to extract values that can become beneficial for everyone. And the driving force behind this industry 4.0 is many. So one of the biggest force is the abundant availability of data. So as we went into this how many years now of the pandemic, most of our lives have basically shifted towards online, right? We do our shopping online. We order like groceries, food, and everything like clothes, we can buy easily online. We interacted with people, like for example, today we interacted both offline and online through Zoom. So basically when we do all of these things online, we generate a lot of data. And this is the abundance of data that basically that is the driving force of this industry. We also have fast connectivity. So nowadays you can get connected to the web really easily and really fast from your mobile phone, from your computers, anywhere in the world. And also nowadays we have customers that want innovative products, especially when it comes to online services, right? So there are demand for such product. And we have nowadays smart machines that can make decisions using machine learning, artificial intelligence. So we have a combination of all these things that drives basically how we do things nowadays, right? And we see in the application, so some of the application are still being developed, for example, the self-driving car, but we already have things, for example, that are in use every day, like, robots that can take, for example, in the warehouse, they can take customers' order and then pack it, for example, in Amazon warehouses in United States. In Indonesia, nowadays you have chatbots that you can use when you interact with companies like your banks, your telecommunication companies, for example, in BRI, right? Nowadays you can talk to Sabrina, which is the chatbot, to ask like, where's the nearest ATM, when's the bank open, and so on and so forth. You also use without maybe in a way you use without knowingly the recommendation, right? For example, if you buy food in GoFood, you actually have a recommendation of what's a good food to buy, right? These are automated product recommendations. Or if you watch movies in Netflix, they give you recommendation of what movies to watch, what TV shows to watch based on what you have watched before and what other people who have watched the same things as you have watched before, right? So all of these are application of this technology. And the Industry 4.0 is driven in the backbone by this technology, which is artificial intelligence. And within artificial intelligence, we have many subfields. Machine learning and deep learning are basically the main drive. And then we also have for these systems are being used to, for example, understand images, in computer vision, or understand text and languages in natural language processing, to interact with people in human-computer interaction, or to make robots that can move naturally like humans, so in robotics. So what is this machine learning? I give a short background for people who might not have the background on machine learning. Basically, machine learning is a field of study whose goal is to make computer systems that can learn from data. So when we think about computer science, we always think about programming, right? So in the traditional programming, basically when we need to make a system that can make a decision based on data, we would enter the rules to the computer using program by writing programs. But nowadays with machine learning, we no longer need to input the rules on how the computer system should behave. What we can input to it is we can give it some example data, and we can give it some example labels of those data. For example, if we want to make a computer system that predict how much a house will cost in a particular area in the city, you just give an example of houses that are in the city and properties of the houses, like how many rooms they have, how old the house is, when is it built, location, how far is it from the central part of the city, and so on and so forth. And the price of the selling price of the house, and using those example of the house and the label, which is the price, the computer will look for, the machine learning program basically will look at the patterns to connect the input, which is the attributes of the house, and the output, which is the price, to finally make decision. So no longer we need to explicitly program the computer what to do. It can learn from the data. So that's intuitively what machine learning does. And machine learning is what underlies most current AI models. And as mentioned, it's a software, an algorithm that learns to make decisions from examples. And examples are this data, like houses that we collect, and we annotate with a label like their price. So in natural language processing, we deal with text. So we have like input in the form of text, for example, in predicting the rating of reviews, right? So if people say, my experience has so far been fantastic, the label should be positive review. If the person say your support team is useless, then the label is negative. So using this data set of examples, we can train the machine learning algorithm so that given a particular input, like we are happy with the service, it can predict that the label is positive. So during training, when it predict that the label is negative, it's basically feedback into the system so that it can make correction. So once it is trained, we can then use the system in testing. So we can input it with text or reviews it has never seen before, and it can predict basically based on the patterns that it has seen during training what the label should be for that particular review. So for example, given the input bad experience with customer support, it can predict based on patterns of people using the word bad and worse and things like that. It can predict that, oh, this this review is negative. Within machine learning itself, currently the most popular algorithm is neural network, and it learns the same thing as other machine learning models. It learns features or patterns from examples, but using neural network architecture. So intuitively, neural network tries to replicate what the neurons do in our brain, right? So when we see an input, basically the neurons fire up. So similar with that kind of analogy, when the neural network receives input, for example, in the form of text, it basically lights up some of the nodes in each layer of the network, and finally it results in the decision. So for example, given the input bad experience with customer support, it can predict that it is a negative review. And so neural network is basically the main, I guess, in most of the machine learning fields right now. It's the driver of most of the technologies. And we've seen, actually, we've interacted with some of this machine learning system in our everyday life. So like I mentioned, you have movie recommendation, you have advertisement in Facebook, you have chatbots, you have, like this face detection in your phone cameras, and so on and so forth. So these are actually machine learning systems that we have interacted with in our everyday life. Not to mention like Google Translate, right? You can translate languages easily now with in the web, right? You can just paste your text and then it translates pretty well, for example, from Indonesian to English. And machine learning is this field within a bigger umbrella, which is the artificial intelligence, which is a larger concept where we want to basically create machines that can do tasks in ways that we think of as intelligent. And so within AI itself, like I mentioned before, we have different fields, like, for example, robotics, basically trying to make artificial intelligence system that can move naturally like humans do, computer vision, AI for making systems that are able to see, like, understand images, and then natural language processing, which is AI that is able to understand languages, whether in the form of speech or text, and so on. So NLP itself uses both machine learning and deep learning, same as the other fields as well. But going back to the pandemic, and because I want to talk about the AI, right, during the pandemic, post-pandemic. So as we all know, the pandemic has created a shift basically in the way we do things. Now we do a lot of our things online, and we do a lot of things remotely, right? And we generate basically a lot of this digital data. And AI itself, in terms of technology, it has been used, for example, to deploy many, systems that help with for healthcare and other purposes. For example, systems to monitor the rise of cases in COVID, how to contain them, screening and tracking patients, or other products outside of healthcare, like how we can reschedule the production delivery for, during the supply chain disruption, and also a lot of support systems for remote activities. Like nowadays, a lot of government services are available online. You can access it through many apps that the government has, right? You can register for tax number online. You can check your vaccination status and update it online using the apps, and so on and so forth. We've also done a lot of education online. So there are many companies that work on creating like software that can support online education. We do a lot of shopping online, like mentioned. So basically AI has enabled a lot of systems that help during the pandemic. And the fear was like, because of this pandemic, there will be a lot of automation, right? Because AI is supporting a lot of the tasks we do every day, that there will be a lot of jobs that get automated and result in the loss of job, right? This is always the fear with AI, like AI will replace people, right? But actually, the truth is that the prediction is not so, like, it's overrated, right? Because as it turns out, the occupations that are mostly affected by COVID-19 are in the service sector. And they are jobs that rely on interpersonal skills, like, you know, hospitality, retail, and so on and so forth. And so whenever you need like personal skill, it's harder to automate. And so they become basically the loss of jobs were not actually realized, right? And also, what happens is that the firm's decision to automate jobs or not actually not just depend on whether the technology is available. It depends also on other combination of factors, like, you know, you have to, you know, invest some money in order to adopt this new technology. You know, you have to supply the skill and labor for automating it, and so on and so forth. So actually, when they say AI will replace jobs, it's not really realized. That's not really what happened. In fact, what might happen is actually that AI technologies may actually help create better quality jobs, less monotonous, therefore, you know, less susceptible to replacement by AI, and more jobs that involve creativity, leadership, interpersonal, organizational skill jobs. So something that will be more, I guess, better quality for us, right? And because of this shift to digital and online activities, the AI technology and the use of AI technologies have made all the companies that provide these services grow very rapidly despite the pandemic. So in the US, actually, the growth of the tech sector, the technology sectors, actually triple the growth of the economy as a whole. And as you can see here, basically in there's a dip in April 2020, but after that, it's going stronger and stronger. And if you look at the two sectors in tech industries that are growing rapidly are the ones that produces softwares, so software publishers, or the one that produces information. And this is propelled basically by the explosion of remote work that requires software to support it, e-commerce that require data and information, and digitalization, right? So in fact, in 2020, the 5 tech superpowers, basically Amazon, Apple, Google, Microsoft, and Facebook, they had combined revenue of more than 1.2 trillion because of from all these activities like home shopping, and then other companies who still have money to do advertising, they probably send those money to these companies to advertise, like Google and Facebook, and then software, like, for example, provided by Microsoft and these companies. And they also, because they are tech companies, they have the possibility to do remote work, right? So they actually cut costs. So they become leaner, but at the same time more profitable. And while the pandemic is happening, they are actually extending because they have the money to do so. For example, Amazon spent like $50 billion to purchase warehouses and also cloud computing, because a lot of our data right now, a lot of the applications we are using live in the cloud, right? So by buying these things, they are actually making their companies more in position to profit even after the pandemic. And if you think about like the scale of this expansion, it's really large. Like the amount of money they spent in 2020 to expand is more than double what ExxonMobil actually spent digging oil and gas from the ground each year. So it's a massive amount of money. But at the same time, not only these large companies are benefiting from the move to digital, the digital adaptations that the pandemic has forced also help smaller businesses then who want to adapt to like this new way of life, like web sales and deliveries. So in general, basically the tech sectors that benefit, like we saw before, like that grows rapidly are the ones that deal with data and information and software, right? So it's either companies that buys and sells data or information for others, or the ones that satisfies customer by providing a differentiated service built on data. For example, right now, if you want to look for say something to buy, right? If you go to the shop itself, you won't know what other people who have bought the product think about the product. But if you go to, for example, Tokopedia, right, you can look at the review of what other people who has bought the product experience with the product. So you have more basically information that you can use to make decision, like whether to buy it or not. So this is why these companies are benefiting from information, because the customers need these differentiated services. There are also companies that deliver information for others, for example, like Google, Facebook, and stuff like that, right? So the tech sector basically that are growing rapidly are the ones that deals with data, and this is not new. Like this has been predicted early 2000, where people are predicting this rise of digitization will produce a lot of data. The data collection is changed, right? Right now, the data is more messy. You have data in both structured and unstructured form, from reviews, which are just like basically people typing, they are not structured. So they are more messy, but you have more data. And using this machine learning, you can basically look for patterns of correlation. So no longer we look for like perfect models to model the data, but rather, we just look for patterns and correlation in the data. And we can actually take all aspects of life and start to turn them into data. For example, some government organization, for example, like New York City governments, they use big data to improve, how they give service to the people. So, for example, last time, before, the use of data, they to check if a building has a risk of fire, they have to send officers to manually inspect the building. And there are so many buildings, so and not enough officers. So what they do is they look at the data that are available about the buildings, and they build a model to find correlations. And using these correlations, they find variables that they never thought before was as correlated with higher risk of fire. For example, whether the building management has applied for, renovation of the outside of the building, like making the outside part of the building better. And apparently, if they do, it correlates with lower risk of, significant fire. So using that data, they are able to choose which building to prioritize to send the officers to manually check. And this actually saved a lot of cost and also reduce the amount of significant fire. So with the amount of data we generate, a lot of companies, government organizations can already collect a lot of data. And unfortunately, this could actually have another side effect, which I will talk about later. But in terms of data, like for computer scientists, right, this is interesting, because if we are able to take this data and we can understand it, we can process it, and we can extract some insights and value from it, this is going to be like for example, by a quote by Halvarian, can be a hugely important skill in the next decades. So it starts from, the pipeline, creating the storage of the data and, collecting the data, cleaning it, analyzing it, building machine learning models on it and presenting it, as well as taking care of the data, making sure it's used properly, it's ethical, it respects privacy and confidentiality of users, and also operationalizing it, which is taking the insights that have been gathered from the data and then turning it into business value. So aside from companies, the data science, basically this explosion of data also has impact on, for example, our scientific process, right? So in the past, when we want to make hypotheses, we start with observation, and then we make the question, and then we formulate the hypothesis, then we start to collect the data, and then check with and test our hypothesis. But now with the availability of data, we can start from the data itself, and then we can explore the data and find questions that we want to ask. So the scientific method itself is also impacted by the availability of data, and especially on interdisciplinary research, data sciences benefited a lot of research that are interdisciplinary. For example, in education, now you have automated tutoring, grading. In psychology, there have been works that measure stress and anxiety, for example, from social media posts. In medicine, there are data science methods that have been used to extract information from physician notes. In public health, there are works that measure epidemiology, like obesity risk from Instagram posts. In economy, there are works to predict, for example, stock price based on news about the companies, and so on and so forth. So there's a lot of impact, not just in terms of companies, but also in scientific domain. And so what must we do to keep up with this revolution, right? So personally, I think there are three things that are needed to prepare for this industrial revolution. First is infrastructure, and then skills and regulation. So in terms of infrastructure, if we want to jump into this bandwagon of like industrial revolution, we need to have fast internet connection, and we need to have powerful computing machineries, for example, GPU servers. So this is at least like the basic things we must have. And then in terms of skills, to prepare our students to this new world, basically where data is the main player, or the main thing that generates value, we need to teach them programming skills, statistics, linear algebra, data science, machine learning, and deep learning. So looking at actually the education level of the data scientists, which is the people who work on data and extract values from data, we can see that most, this is from Kaggle State of Data Science and Machine Learning 2021. So they have conducted this survey over 5 years, and they see that a lot of data scientists nowadays are basically having master's or doctoral degree, but increasingly also bachelor degree. So people start earlier now, I guess, in terms of learning these skills. And then most popular platforms year over year, aside from university, people actually also do continuous learning through, for example, platform like Coursera, Udemy, and so on. And then programming wise, most data scientists have like several years of programming in the experience, but increasingly globally, there are like people who have worked within 1 to 3 years of programming before they become data scientists. And in terms of machine learning in the US, because they are leading in the type of machine learning algorithms and innovation and so on, there are more people who knows longer about machine learning than globally. But globally, people are, I think, really want to take up these machine learning skills, especially in the past 1 to 2 years. And in terms of framework, we can see that, machine learning framework is one of the things that is used mostly by data scientists like scikit-learn, but also a growing number is using PyTorch, which is the dominant deep learning framework. And in terms of cloud, because everything data systems now are living and being deployed in the cloud, we also need skills in terms of preparing our students in how to manage and deploy systems in the cloud. So Amazon Web Services is one of the most popular cloud provider. In terms of salary, this is probably interesting for the students because we can see that globally, the distribution, I think there are some data scientists that get paid really a lot in the US mostly, right? So they, in rupiah, I guess this is in US dollar per year, they can earn like up to 125,000, which is about 2 billion rupiah, right, a year. So this is a significant value. And also like in terms of increasingly, they are also getting paid more. For example, in USA, Germany, Japan, and Brazil. But mostly, I think these 3 countries are the ones that pay the most for the data scientists. And about companies, actually, instead of just companies that are big tech companies employing data scientists, increasingly there are startups that have position opening for data scientists. You can see here, like companies that are very small, 0 to 49 employees, are the one that are also looking for data scientists. Unfortunately, the gender distribution, on the other hand, is not really changing over time. Mostly data science is dominated by men. So I think preparing, especially our students, female students, who want to work in data science is also equally important. But that's one side, is excitement, a lot of growth, but at the same time, we have to think about the data that are being generated and being used to power these systems, right? So because we generate a lot of data everywhere, like when we use government application, we put our data there. When we post in social media, we have some of our data there. When we go to hospital, we have some of our data there. So all of these things can be connected and linked together. So for example, if I know your social media, I can look up, for example, your LinkedIn and see what job you have, right? And then from LinkedIn, I can link it up to Glassdoor and see how much money you roughly make, right? So basically, with the rise of data, our life becomes mostly being stored in the cloud, right? So we have social life, we have career, we have our search history, and this can provide many advantages. So the companies can use this information to create better personalized service for us, right? But it has a big disadvantage, which is also security and privacy breaches, because now we basically don't have control over who is using our data and for what, right? So corporate leakage to government data, company data is one of the big disadvantages of this. And also we don't have the rights to access our own data, right? We don't even know where it's being stored and so on and so forth. And this can be used to also make systems that can be disadvantageous to us. For example, systems that can predict whether or not you will commit crime, right? So since all these systems are based on patterns, they are based on other people that are similar to you, but not necessarily you. It's in a way taking away your free will, right? So because you are thought of as being so and so because other people who are similar to you has done so and so, right? So ultimately, this is a profound social change and challenge, and that will become the moral issue. So because in theoretically, nobody should know more about you than you do, but in this current world, we no longer have control over that. And because companies are using this data, it's a valuable asset, it's a valuable product. They can use it to create more services for us. They can link their data together. So when you search in Google, next time you open Facebook in another device, they can show you the advertisement of the things you just searched, even though you use 2 different devices to do it. So all these things are basically, it's hard to manage, right? And then government, at the same time, they want to make services available to us online more easily, less pen and paper, more automation. But, each government department, they might have separate systems, they might have separate vendors that build those systems for them. And then when they interact, they share the data. So, and then there's also the push that, law enforcement should know what everyone else knows. So this creates like a problem because there's basically less clear what access each government department can have to the data. And so the question becomes, who has access to what, who is responsible, and we are all stakeholders in this. So as a consumers, we also have relationship with the data. As companies who use the data, they also have relationship to the data, government as well. So with great data, of course, comes great responsibilities for all of us to try and protect this data. And unfortunately, data breach, because of this massive amount of data that is available online, is increasing, right? So this is the annual number of data breaches. As you can see, it's increasing, and the millions of records exposed as well. And recently in Indonesia itself, we have also the problem with the hackers leaking sensitive data. Over 105 million of Indonesian citizens, like data of your basically ID number, which can be linked to find your address and so on and so forth, your phone number, your email, which then can be used to open bank account, open loan, and so on. So it's a massive problem. And so at the end of the day, what can we do, right? So there is a problem with, balancing the rights of the people who generate this data and the functionality that the government and companies want to create. As people and consumers, we have rights to privacy. We have the rights to be able to control our data. We should be able to access it and delete it when we want to, and other rights to it. But companies also have rights in terms of their intellectual property, so they are not sharing the data and so on and so forth. And at the same time, government wants to provide services to the people. And so regulations, policy, and laws are needed. So this is one of the 3 things I mentioned to create capacities for Industrial Revolution 4.0, because basically the right to privacy is a basic human right. We should be able to have control of our data, because the data can impact our identity, it can impact our relationship to others. And so regulations are needed on how, our personal data are collected and how they are managed, and how organizations or companies or institutions that gather this data can protect the data to ensure this privacy. So in summary, I believe these 3 are the most important things to create capacities for Industrial Revolution 4.0. Aside from infrastructure and skills, we also need regulations. So that's all I have for my talk. Thank you very much. Sorry, I cannot hear. I think the microphone is not.
Yeah. Hello?
Yeah, now it's
Okay. I'm sorry. Yes, thank you very much, Professor Dery Wijaya, for interesting presentation. Now let's move to the discussion session. So for the first, Karel Sensei, are you there?
Yeah.
Yeah. Okay. So for the first question, maybe for online participant, please kindly press raise hand button and then ask the question directly. And for the on-site participant, please kindly raise your hand and then ask the question. For Professor Karel Swadlenka first. Is there any question?
Can I have a question for Dr. Karel?
Yes, please. Ibu Ana Safitri.
Okay, thank you, Ibu Sophie. As our moderator, I have question for Dr. Karel about your mathematical modeling and simulation. So can it apply, can this mathematical modeling and simulation can be applied for maybe pattern in biomolecular study? For example, the growth of the malignant tumor or the growth of the cancer cells, maybe because my field of study is chemistry, especially in biochemistry. So I'm wondering if your mathematical modeling can be applied in biomolecular study. Thank you.
Thank you for the question. Yes, this model was designed to address plasticity in crystal lattices. So maybe it's not a good idea to use it as it is for biomolecular applications. But of course, a very similar model can address such problems like tumor growth. I have been also working on this, but the model is a little different. But if you are interested, I am happy to discuss with you maybe over email. But this model is a little different from what is needed in biomolecular applications.
Thank you very much for your answer.
Thank you.
But, yeah, that's why I asked, because I read your CV. You also do some molecular modeling in this area in biomolecular study.
Yes, yes.
Maybe
yes.
not in your talk this morning.
Yeah, it was
in
not
your-
related, but yeah.
In your
Yeah,
other
definitely, if we
research.
can, if we can discuss it, would be nice. Yeah.
Yeah, that's really interesting topic, I think. Thank you, Bu Sophie.
Yes, thank you, Anna, for the question. And is there other question for Associate Professor Karel Swadlenka? For online participants, still there is nobody present. Okay, maybe from the chat. Yes. Yes. Karel Sensei, I have question. So actually, how to formulate the associate energy functional in this case? I mean, we can discuss in other problem, right? That energy functional is like automatically constructed for other cases, but for this, when I saw the energy functional formula, it is like integration of gamma square, which gamma is amount of shear
Yes.
like this, and it is also how to say, it is also satisfied for other cases. This is the first question. And the second question, how to set the boundary condition for the numerical simulation that you show in your presentation? Thank you.
Mhm. Thank you for the questions. Very, very nice questions. So for the energy functional form, I use gamma squared. It's actually where there is a big discussion in between physical experts on what kind of energy is good for the to express the plastic deformation, let's say the energy stored in crystal defects like dislocations. So yeah, the question is very good because it is a topic of research still. So this is one of the simple forms that is like approved by physicists, but that does not mean that is the correct one or the best one. Yeah. So yeah, it's not clear what yeah, depends on the material and also on what we want to see. Yeah. And for the boundary conditions, I explained without sharing screen. Yeah, so we are compressing the material from above, so the upper edge has a prescribed displacement. So the velocity of the upper edge is prescribed as a boundary condition, so it depends on time. And the lower edge is fixed, and the lateral boundaries can move only in the vertical direction. So I implement in the finite element approximation, I implement the conditions like that.
Yes, okay. Thank you very much, Sensei, for the answer. Is there any more question for Associate Professor Karel Swadlenka? Yes, please.
Thank you. My question is for Professor Wijaya. I would like if you have met a kind of case where people have a conflict between personal people and a company that use their data. Do you have any story about that? Thank you.
Yeah, so there are a couple of cases. One thing that was interesting to me, because my area was natural language processing and knowledge bases, is this case where somebody searched for their name in Google, and the result that was shown was the result of somebody else who has already passed away. And but with the picture of the correct person, but it mentioned that the person already passed away, already died, right? So this journalist, actually New York Times journalist, wanted to fix that because you don't want to be thought of as dead when you're alive. So she asked Google, how can they fix the data about her, right? So turns out it takes a lot of time to actually find out, first of all, where the data is stored, and then after that, like actually fixing the data. And because this person is a journalist, they can write about it, they can complain about it to Google, and they listen and fix the data. But imagine if it's us, right? And if we have like data that is not accurate being displayed on the web, right? How can we fix it? So this is a problem, not just for the journalist, but it could be for everyone. And at this time, basically, we have no access to the data. We cannot delete it if it's inaccurate, if we don't like it, if we don't want it to be shared. Once it's out there, we cannot do anything about it. So And like with data breaches, there's a lot of also identity thefts that have happened in the US, for example, where people actually take out loan in your name and didn't pay up. And then you get calls from debt collectors and so on and so forth. So with the current breach that happens in Indonesia, I think it will become a problem, especially because of the recent breach is our identity, like identity number and so on and so forth are being breached. And so they can be used to open accounts, rent a house, and so on and so forth, which can be a problem. Yeah.
Is the answer is enough, Bapak Yuwono? Okay, thank you. Yes. Okay. Now next, move to the question for Associate Professor Derry. Yes, there is question in the chat column. Okay, from Yusuf. What is the minimum number of dataset in artificial intelligence to create a valid and acceptable model, and how many % is the maximum error value of an AI model that can be accepted?
Yeah. So the answer to that question depends. So different tasks have different level of difficulties, and also it depends on the model that you're using. So the number of data that you would need, for example, to do certain tasks might be different from the number of data you need to do other tasks. For example, in sentiment detection, for example, to see whether a review has positive, negative, or neutral. For this kind of tasks that you can use, for example, some pre-trained model like that have been pre-trained on lots of data, not necessarily sentiment data, just like Wikipedia books and so on. You can get away, I think, with like not that much amount of data, maybe just thousands of data samples. That means like reviews and label, if it's in English. But if you are thinking of doing it in Indonesian, then you would need like probably more data and models that have been pre-trained on Indonesian language. As a comparison, to do a machine translation, a good machine translation model, you would need millions of examples. So thousands or hundreds of thousands are not enough to train a machine translation model. Because in machine translation, the label is not just 3, right? It's not just positive, negative, or neutral. When you want to create a translation, the size of the output is basically the vocabulary of the language. So the vocabulary of a language could be 200,000 words. So the space, the output space is much bigger, and you need more data to train the model. So it varies from task to task. And in terms of accuracy as well, it depends on the task and the area. For example, in the area of communication and journalism, to publish in a reputable journal, you have to have at least 80% accuracy in your model. But in computer science, on the other hand, right, if there is no fix like you have to be at least 80%, but rather like what have existing models do on that task and on that data. And if you can beat that with like performance difference that is significant, then you can publish. But in real deployment of the system, this is another thing. So it's between publication and deployment, right? In deployment of the system, it depends on how critical the system is, right? So if the system is critical, that means it's a system that can be used by judges to assign how long somebody should be punished for a crime. then that system will need to have really high precision, for example. But for systems that are used in, that means when it says that somebody is going to do certain crime, it has to be really precise. So it cannot make a mistake, right? Otherwise, an innocent person might be put in jail, even though these systems are not used automatically. They are used to give what do you call that, suggestion or like advice to the judge who finally makes the decision. But still, like if it makes a wrong advice, then it might lead to a bad decision. So for those kind of systems that are critical, you know, it's not enough to have, say, 80% precision, right? You need to have like really high precision. So yeah, so the answer is it depends. It depends on the task, and it depends on the goal, what you are going to use the systems for.
Okay, thank you for the answer, Professor Derry. I think it is clear, right? And then for other question, yes, please, Bapak Saiful.
Good morning, everyone. I'm Saiful from Mathematics Department, Brawijaya University. Now, artificial intelligence grow very fast in line with data technology and Internet of Things. But the problem is how to choose an appropriate machine learning method or artificial intelligence method to solve the problems. Are there any consideration to choose the appropriate machine learning method? Thank you.
Thank you. Yeah, this is a great question, which is actually not doesn't have a straightforward answer, because depends on the application and the amount of training data you have. The machine learning model that you need to choose will vary. So for example, if you want to do sentiment analysis and you have lots of data, then a simple machine learning model like naive Bayes or logistic regression would work. And in fact, like the Kaggle survey that I mentioned just now, if you look at the most commonly used algorithms, they are still the simpler algorithms like regression and decision trees and so on and so forth. Because the more complex models like these deep learning models, neural network models, they require more data to train. But it also depends on the task. If the task is simple and you have lots of data, then simple models would work. But if the task is complex and you have few data, then a very complex model will not be able to work very well for it if you don't have enough data to train. So it depends on the difficulty of the task and the amount of data you have. And so if that's why I think machine learning skills is one of the important skills to give like foundational machine learning to the students so that they can think in terms of like the inner working of the model. Also, it depends on the user. So in like, for example, hospital and medical purposes, more complicated model like neural network deep learning models may not be appropriate because they are not explainable. You know, you give them an input and then the output says this person should be admitted to the ICU. If you give that model to the doctor will say, why? You know, there is no explanation. That's why decision tree, for example, are mostly more commonly used in the healthcare setting than say state-of-the-art deep learning models. So it depends on all these factors basically. And I think when students learn machine learning from the foundation, they will be able to choose which model is most appropriate because they know the inner workings of the models. Yeah, so I think it's one of the important skills, and it is really hard. And unless you you have been learning and practicing it, it's not straightforward to answer which model is best for your particular use case. Yeah.
Yes, okay. Thank you very much, Prof. Ferry, for the answer. It is enough, right, Bapak Saiful? Yes, okay. And then there is one more question in the chat room from Muhammad Master Mahasin. Or do you want to ask the question directly? Okay, so maybe I will read the question. So I'm very interested to deep learning development, especially for computer vision based on physical concept using deep learning. I have read papers dealing with generating synthetic data for training models in computer vision, such as training autonomous car models using game environment like GTA. Can the method of generating synthetic data that will be used for model training also can be used in case of the NLP model, maybe for sentiment analysis or the other tasks? Thank you.
Yeah, this is a very good question. In fact, this is an open research area in natural language processing because we saw that this data augmentation, we call it, has been very useful in computer vision. Like you can crop the image, you can shift it, you can flip it, and then you can get more data to train your model and make the model more robust to noises. How can we do the same in NLP? It's an open research question. And so far, what people have done is actually, depending on the task, there are different data augmentation techniques that you can use. So for example, for sentiment analysis, you can change, you can paraphrase the words. So instead of bad, you can say not good, things like that. So basically using the paraphrasing, you can paraphrase a sentence to have more sentences. So that's one way. But I think we also want to have a more general way of doing data augmentation in NLP, so not task specific, that is in similar form like people do in computer vision. So yeah, it is a very interesting area, data augmentation, especially in NLP, and it relates to other hot area in machine learning, which is like contrastive learning and things like that. So how we can create more synthetic data and then make data that are similar, more closer together in the representation space than the less similar data, So not just creating augmentation for positive example, but also negative examples, and then using contrastive learning to separate them. So yeah, this is a very I would say an exciting space in NLP research right now. Yeah.
Yes. Okay, thank you very much for the answer. Because of the time is over, let's close this session. So thank you again for our great keynote speakers, Associate Professor Karel Swadenka from Kyoto University, and also Associate Professor Dedi Wijaya from Boston University. And please give applause for them. Yes. Before I give it back to the Master of Ceremony, I also would like to thank for all the participants, both online participant and on-site participant. And please enjoy all of the conference program. Have a nice day, and Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you.
Thank you, Sophie. We would like to conclude our second plenary session until 12 p.m. Now we will have an hour lunch break. We will start our parallel session in 1 p.m. We have 3 rooms. Room 1 is hybrid online room. hybrid, so you can join this room 1 only, while room 2 and 3 is for on-site only. So for the all BaSiC 2022 attendance, we will have 1 hour lunch break starting from now, and we will close this Zoom meeting for plenary session. Thank you very much for your attention. See you at 1. Lunch is outside this ballroom, so just behind this ballroom number 1. So you can go outside and this left-hand side. Thank you. Musola is behind this stage, so you can go outside and turn to the right, and there is a prayer room just behind this ballroom, this stage. Oh, because we will set this room as our parallel room. If you go outside this room, please bring together with you all your belongings, your bags, your laptop. Don't leave your laptop or your bags here. We will set up this room for parallel conference room. Thank you.